Welcome to A Regenerative Future with Matt Powers. I'm your host, Matt Powers. This is a podcast and YouTube show about living more regeneratively, how we can do it in our daily lives, how we can regenerate the planet, how we can regenerate our economy, our culture, how we can apply permaculture ethics to all aspects of life. And we talk to people from around the world who are living it, who are doing it, who are exploring it, who are researching it, who are exposing these amazing scientific truths, universal principles, realities all around us. And it's raining in our area of California again, and so it's a perfect time to talk about the fourth phase of water. Now, this is not liquid water, this is not vapor, and this is not frozen water. This is gel, a very special kind of gel that forms on all hydrophilic surfaces and grows 10 times as great in the sun or in the presence of infrared energy, light. This is fourth phase water, and its discovery and its description and kind of pronouncement to the world has been largely through a small group of people, and it's been spearheaded by our guest today, Dr. Gerald Pollack. If you've seen his TED Talk, then you know what we're talking about, and you'll be able to delve into the conversation at a higher level and see how we explore some things. If you've not seen it, please check it out. It's the fourth phase of water, easy water, exclusion zone water, it's also known as, and it changes everything. As he talks about in this, he says, well, the separate things you're describing are all one thing. And that's what easy water or fourth phase water does. It allows us to see a paradigm of understanding. The reason clay and biochar can hold so many nutrients, can have so much biology in the soil around them, is because that they have the surface area and they're hydrophilic, so they form this huge relationship with water. I mean, biochar can hold almost 3 times as much water as its mass, and it does that electrically. And so when the water is being held there, it can now hold life there and hold nutrients. If you pour hard water through easy water, through fourth phase water, it comes out as soft water because the cations are held. So when we think about cations and anions, and we talk about even when we think about cells, because cell water is gel water, is fourth phase water. And so the way that things go in and out of cells, the way that everything works, all life is affected. The way roots work, everything is affected by fourth phase water. And it's something that you probably have seen in your life. It's something that you probably will immediately resonate and recognize once we delve into this. So dive deep with us in this new episode of A Regenerative Future. Thank you so much for watching. Here we go. So what led to the discovery of the fourth phase of water, and what is it exactly? Because for me, when I saw you first describe it, I had to rewind it, and then it felt like it's something that's been part of my whole life. So maybe you can help us with that.
Well, it has been part of your life because your body is filled with it. So you might not have realized that it was part of your life, but it was. In fact, it's been part of our lives and everybody's lives since time immemorial. So we all know that we all learn that water has 3 phases: solid, liquid, and vapor. And the idea of a fourth phase, it was actually implicit. There have been quite a few people from starting from 100 years ago who were saying, hey, something is not right about our understanding of water, because there are too many, in the scientific field of water, there are too many anomalies, too many things that don't fit the paradigm, the 3-phase paradigm. And most of us have a tendency to take those items that don't fit and sweep them under the rug. Oh, somebody else will figure it out later. The central theory that we're all accustomed to thinking of, the three phases, must be right because it's been around for so many years that how could it be wrong? But there reaches a point when the number of anomalies grows so large, as to be overwhelming. You have to step back and ask yourself, is there something that's fundamentally wrong with our understanding? And that's where I started. I'll just give you some background on maybe on how it all began, because that was your question. So we were studying muscle contraction and the molecular mechanism of how muscles contract, the interaction of myosin and actin proteins, and it was great fun. But unfortunately, I didn't make I made progress, but I didn't really change the field at all. So for a little background, the field was dominated by a very famous Nobel laureate. His name was Sir Andrew Huxley, and he was a great man. He'd walk into the room and there was a big hush. Oh, God has just walked in, something like that. And so trying to challenge someone like that is no easy task. No. And I tried doing it because the theory, almost every experiment we did demonstrated that the results didn't fit the theory. And some of those results were profoundly inconsistent. There was no way that it worked. But I didn't make much progress because the field, it was heavily entrenched, and many scientists in the field were a little bit reluctant to follow someone who seemingly had a radical idea. So we produced evidence after evidence after evidence, and nobody paid attention. The people in the field would just stick to their devotion. It's a bit like some people's devotion to, politically, to our previous president. It's in a way similar. So it was really difficult to make a lot of progress. But I was not disgruntled. I remained optimistic because I was excited because we had an idea of how it might work, and that's what segues into your question, because I was invited to attend a symposium in Budapest. It was a Hungarian guy who was supposed to work in my laboratory, and I picked him up and his wife from the airport, and we're driving back to my house. And he said, you have to go to Hungary because there's a really important symposium coming up. And the symposium is designed to honor the life's work of a biophysicist who recently passed. And he had two fields. One was muscle contraction and the other is water. And you should be the representative of the field of muscle contraction, because this guy's points of view were not so distinct from your own, and you would be a good representative of that. So I'm thinking, okay, why not? So I go, and there I meet someone or many people who were dealing with water. And the premier person was a guy named Gilbert Ling, L-I-N-G, Chinese guy. He just passed, unfortunately, within the past year, almost reaching 100. And Gilbert came from China. He was in the first cohort of Chinese scientists, a group of 3 they chose from all over China. They picked the 3 best to come to the US. And so Gilbert was the biologist, and then there was a physicist and a chemist. And the physicist went on to win a Nobel Prize. Gilbert should have won a Nobel Prize, and the rumors are that all 3 of them thought that Gilbert Ling was the cleverest of all 3. But he went on, and Gilbert went on to study water. He was studying a few things, but one of the principal things was water. And I knew I had known about it because I had been a graduate student in Philadelphia, University of Pennsylvania, and he was living in Philadelphia. And so one day at some dinner, my guy sitting next to me, hey, you see that guy 3 tables down there? That's Gilbert Ling. He's the crazy guy who thinks that the water inside the cell is different from the water in my cup here. How so? Oh yeah, he thinks that the molecules of water are all lined up. He called it structured water. He said that the water, biological water, is not at all like ordinary water. And just to make a link before I finish the discussion of this, that's what led to 4th phase of water, or as we call it, EZ water. It was his work. He was the inspiration. So I went to that meeting. I met Gilbert. We hit it off. And I also met a dozen other people whose evidence supported Gilbert's idea that the water inside the cell was different from ordinary water. I was totally fascinated, but I have a tendency to be overly excited about ideas that I sometimes hear about. So I decided I'm going to test this on some of my students and postdocs. So I got one of Gilbert's books, and I gave it to a handful of students, postdocs, and every one of them came back and said the same thing. Boy, this looks really, really interesting. And if this guy is right, everything else is wrong about biology. So, that of course gets me excited, right? It gets you excited too. I can see by the smile on your face. I'm thinking, okay, well, what's the next step? I'm enthusiastic and my students are enthusiastic, and there's a big problem. So what's the big problem? The big problem is that Gilbert's writing style is, well, I should say almost impenetrable. It's really hard to read through. When Gilbert writes, he sits down at his word processor or typewriter. A lot of the stuff came earlier, and he bats it out, and that's it. And it gets published. And for those of us who are not as gifted as Gilbert Ling, it's really hard to follow. And so I took it upon myself to write a book about Gilbert Ling's ideas. And I wrote, the book is, I know you have a copy handy, Cells, Gels, and the Engines of Life. Yeah, it's got a pretty cover. Well, and the inside is, well, so it starts out describing Gilbert's ideas in a way that I think are more accessible. By the way, there's a book that follows that. It's called The 4th Phase of Water, and I guess we'll talk about some of the stuff that's in that book, because there's a lot that's in that book, and it's become very popular. But that book, actually, the one that you just put up, it is less popular. Some people, some reviewers commented that, oh, this is just more of Gilbert Ling, and everybody knows that Gilbert Ling is wrong, and so don't take this book seriously. And other folks, like a colleague at Harvard, who has a big program in biology, wrote something like, quote, "This is a 304-page preface to the future of cell biology." I like that one, et cetera, et cetera. So anyway, in writing this book, trying to do something for humanity, or for science at least, to make these ideas accessible, I went beyond what Gilbert expected. I went on to think about how biology really works and how the water interacts with biology. And the conclusion that I came to, based on a lot of evidence, is that this structured water that Gilbert was talking about, structured water is critical for essentially everything that biology does. And the way, just to summarize quickly, without citing any evidence whatsoever, the evidence is in the book. The idea is when a cell is at rest, when it's not doing anything, it's kind of lounging around like Hawaii, you know, in the sun, whatever. The water is essentially all the water inside the cell is structured. Not necessarily as Gilbert suggested. I'll get into that later if you ask me, but it's different from ordinary liquid water. And then when the cell wants to do something, for example, if a muscle cell wants to contract, two things happen, two principal things. First is the water undergoes a transition from this kind of structured water to ordinary liquid water. And then when it's finished contracting, that water returns to the structured water, and that actually requires energy to bring it back to the structured state. That's the initiator of events. That initiator works in muscle cells, it works in nerve cells, it works in secretory cells, it works in mitosis, and it's all over. And it's absolutely central to, according to the evidence, everything that happens in biology. It's not just the water that changes. Along with the change in water is a change in protein. The proteins fold. And the protein folding is what brings about action, you see. So in the case of the muscle cell, muscle is stimulated to contract. The water undergoes the transition from structured to unstructured, which allows the proteins to undergo their folding, which generates tension and shortening. And then when it's all over, it returns back again. So anyway, I may be going into more detail than you asked, but the point is, this is how it all started. And of course, after writing the book, you know, I got a lab full of eager, clever students, postdocs, and I decided it's time to change. It's time to move from the field of muscle contraction, where we were, I think, doing quite well, although, as I pointed out, the establishment in the field was not moved one bit. and people in the field actually think that the problem is solved. And that's why young people are not going into that field, because, you know, who wants to beat a dead horse? It's all done, it's solved. We're going to go into something more important like genetics or something like this. And so the field is, I think, moribund. It's not progressing a whole lot. So we then decided, we decided to stop studying muscles and start studying water. And everything opened up, and that's how we got into the field and initiated experiments. And I've been lucky enough to have really outstanding people in the laboratory, and somehow managed to get enough in the way of funding to support those people. I don't know how, because usually radicals don't get money. I've been very lucky, and that's where we started.
So when we're talking about easy water, or the fourth phase of water, and we say it's the gel form of water, I think it's easy for people to go, oh, gels. I think of gels as all these different like things and products and all this stuff, but it's very specific, right? The structure of it's specific.
Yeah, the structure of a gel is specific. Usually a gel contains a matrix of some sort. It could be a protein or a polymer and water. If it's a so-called hydrogel, the gel that is containing water. And we found that the gel actually is built of structured water. It's not ordinary water. You know, if it were ordinary water, then it would sort of leak out, right? But you know, but this is like highly viscous, almost like honey, you see, and it sticks to the matrix, the protein or polymer matrix surfaces, and stays inside the gel. It's like you. If you were to cut yourself or subject yourself to serious surgery, if the water inside your cells were liquid water, it would come pouring out like a faucet. You know, you cut yourself right here, and all the water comes out, and you dehydrate. You become and you die. But it doesn't happen. The water doesn't come out. Blood might come out because you've cut vessels, but the water from inside the cells doesn't just pour out, which is very simple evidence that the water inside your body is more like gel water, highly viscous and stuck to those surfaces, rather than liquid water that comes out. See, so that's rather simple. It's sort of like middle school evidence kind of thing.
The idea that we could add to our 3D water in our body, or not 3D water, add to our fourth phase water, it seems like this is like the mechanical route that people have talked about doing. But then you have like Zach Bush, who's talking about raising, the charge, on the outside of our cells with Restore. And then in my mind, I'm like, okay, well, we're always trying to like raise the paramagnetism of the soil, or at least, to get it to a good spot where it can hold more water. And then there's the theory that the higher the paramagnetism, the more fourth phase water. So I wonder if raising the charge on our bodies, raising the energy of our bodies, would actually allow us to be more hydrated.
Yeah, so you're on something important. And the various possibilities that you suggest or options are all the same. You see,
Mm-hmm.
because what we found is that the so-called structured water, which we call fourth phase water, is, as I mentioned, different from what Gilbert Ling was suggesting, which was like soldiers standing at attention, all lined up, and but it's not like that. We found in our studies that well, the main point is that the water, this fourth phase water, is not neutral like ordinary water. It has negative charge, and the cell has negative charge inside. So the two fit together very well. And in fact, I've written some papers on the idea that the reason why the cell has negative charge is not due to membrane pumps or channels at all, which is the current view, but due to the water that's inside the cell. The fourth phase water is negatively charged. So the water actually comes in, the real structure of the water, at least we think, based on the evidence, is not, as I said, that like molecules just lined up in order. It's sheets that form. So imagine some material surface that is hydrophilic. It means water loving. It means
Right.
if you were to drop a droplet, it spreads out, as opposed to hydrophobic, like Teflon, where the water beads up. So it's hydrophilic. What happens is the water that meets the surface, the first layer undergoes a transition to some sheet-like structure that's hexagonal in nature, a honeycomb sheet. And then the next one builds out of the water that's out here. Next one builds on top of the first one. And the next one builds on top of that one, etc. And these sheets keep building. And each sheet has a kind of hexagonal structure. And each sheet is negatively charged. Since all of this forms from water, H2O, water is neutral. And so you ask, well, gee, wait a second. If this is all negatively charged, what happens to the positive part of the water, the H plus, OH minus? And it gets expelled. And so you have a situation where you have this hydrophilic surface. You have lots of sheets of this stuff with negative charge. And beyond that are all the protons. So you've got negative here and positive here. That's a battery, you see. And that gives you energy. So your body, you mentioned energy, you mentioned charge, you mentioned structured water. All of them are bundled into one package. I hope that's clear. If not, please ask and I'll try to clarify.
So that means that the way that plants interact with cations and anions and everything is really just a byproduct of the way fourth phase water works. And so plants,
I think so.
This and
Yes.
interacted with fourth phase water and developed with fourth phase water as the initial setting how to take in cations, the way that, you know, an agriculturist would think, you know what I mean? They're like, oh, the cations go in. It's like, well, there's an ambassador there.
Yeah. Well, yeah, I'm afraid that some of this stuff is not correct. And
Yeah.
in the book that you held up, I discuss the issue of channels right at the beginning, and why, in my view, it's logically impossible. Besides evidence that it's impossible. I don't know, we could go into it, but maybe it's a
Yeah, let's go
digression
into
from
it.
the kinds of questions. Okay, well, it's very simple. So the first, well, I don't remember which is the first channel that was discovered, maybe for sodium, I think, but it doesn't matter. As of now, according to one of my students who went into the field, the number of channels is somewhere, I think, between 1,000 and 2,000 channels, and each one is specific, said to be specific for a particular ion or a particular substance. So you can imagine a membrane, and situated on this membrane are this huge array of channels. You know, so many of them that you actually wonder where they can all fit. But here's the logic. Think of, instead of thinking of a membrane, think of a wall with a dog door. You know, so there's a door for the dog, and then there's a door for the cat, and then there's a door for the mouse. Each one is a different size, and the idea is each one of these doors should be, like the channels, should be unique for that species. So the dog comes around and opens the dog door and walks out. And the question is, what prevents the cat from going out the same door, right? Easily fits through. Might not appreciate the dog so much, but it can go through also, you see. And if so, then why should there be a special door for the cat? Who needs it? You don't need it. And now take the cat door. So the cat door is meant for the cat, and the cat might go through, but at the same time, the mouse goes through, and the cockroaches go through, and you know, anything smaller goes through. And somehow this door magically needs to have proper apparatus, or properly constructed, to make sure that everything smaller gets excluded. It's like having a pipe, you know, that lets a football through, or a basketball. What prevents the golf ball from going through? Right. And every channel needs to do this, all 1,000. You know, figure out even a hypothesis to explain how every single channel must be able to exclude whatever is smaller. It just doesn't make sense. So that's one argument why the channel, the idea of channels, it simply doesn't work. Now, if you go to pumps, membrane pumps, the other half of the gadgetry, it was actually Gilbert Ling early on who said that something is wrong here, and it's really major. And his view has never been formally challenged by anybody, as far as he knew, and I know. And it's very simple. When it was the sodium pump that was said to, was the first one that was discovered, got a Nobel Prize, et cetera, et cetera. And at the time, it was acknowledged that 1/3 of the energy of the cell goes to pumping the sodium out. So you're using 1/3 of the energy, of your body's energy, to keep the sodium out for some reason. And you know, that was when there was only one pump. Now there are, if I recall the numbers correctly, somewhere between 2,000 or 3,000 of these. You know, everyone wants to win a Nobel Prize. You know, oh, I got a new pump here to explain this. But so Gilbert did an experiment. What he did was he poisoned the cell. Basically, you know, you're pulling the plug on the pump. And so if you pull the plug, the pump isn't working anymore, or the putative pump is not working anymore. And whatever the pump does, it fails, because the pump can't do it anymore. And so he was interested in a few features. One of them was the electrical potential between inside and outside of the cell. So he poisoned the pump, and he gave it a cocktail, that would make the Russian use of these nerve agents seem paltry or almost ineffective compared to the way he poisoned the cell. So for sure, that pump was not plugged in. I even cut the cord. And still, for 8 hours, this difference in the electrical potential between inside and outside, supposedly the result of this pump, was maintained. You see, so he made a computation about how much energy the cell could plausibly have, even despite the poisoning, and still it was off by 2 orders of magnitude.
Wow.
So, yeah, so it doesn't work. Nobody ever challenged this. Nobody. And so it stands today, but also nobody pays attention to it, you see. So he proved that there's something wrong with this concept. So we're now thinking about, or we're now dealing with membrane pumps and membrane channels as necessary features of cell behavior. And the funny thing is, you were about to ask something. I was gonna.
Why do you think that is? Why do you think that no one?
Why is what?
Attention to these big discoveries? Because it's too difficult to start over, to unearth.
Yeah. Well, no, I mean, no, I don't think that's it exactly. It's a matter of territory. So suppose you were the guy to discover the XYZ channel. You wave your flag. Hey, I'm the guy who's started, right? And someone comes along and says, the whole thing is nonsense. How would you feel?
Yeah.
It's human nature. You'd feel, hey, if this guy is right, I'm demolished. My standing in scientific society is instantly gone. There's no way out. What am I going to do? So it's scary, and we're talking human nature. People don't like to feel threatened. If they feel threatened, they will respond in kind, some more than others. So we like to feel important. And if our claim to fame is suddenly going to be wiped away, the best thing to do is just, ignore it or challenge it or whatever. And best thing is ignore it. I'll wait till somebody else deals with it. For the time being, I'll just stick to what I like. So this is a pervasive problem in all of science. And it's one of the reasons why, for example, if I were to ask you, how many scientific revolutions can you count that have taken place in the past, let's say, 30 years, 40 years? Now you're about to respond by saying, oh yeah, iPhones and iPads and whatever. I'm talking not about technology. I'm talking about science.
Yeah.
Something equivalent to the splitting of the atom, I think 75 years ago, and the genetic sequence 65 years ago. They've changed everybody's life in one way or another. But I ask you, can you think about another scientific revolution that's occurred more recently, let's say 30 years, that has succeeded, not promised this, succeeded in changing your life? And please don't tell me Higgs boson, because that hasn't changed your life a whole lot.
I think that mycology has changed my understanding of everything. And I feel like there's a lot of things you can study in soil that are pretty old and amazing, that people were thinking about this stuff at an earlier time period. But in mycology, and like maybe even in the endophytes, getting even more specific, it's like there's just not much written about certain topics. And like plant growth promoting rhizobacteria, mycorrhizae, fungi, all these different things that we really didn't understand when I was a kid. Now, I mean, the way I grow food, I don't think about, anything but the soil first. Like I think about the soil, I think about the life that goes into it. I think about the partnerships between the life. I'm like, all right, I'm going to pair this mycorrhizae with this bacteria, and 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 so I would say that that has been changed. I mean, it's changed how I look at everything, micro to macro. I think about the biochemistry of everything now, and I never was like that as a kid. I just wanted to play music.
And I bet you're good at it too with your guitar.
I played with I played in New York City, and before my wife got cancer, that's how I
Oh.
paid for our apartment in Brooklyn. So I was pretty good at it. But rock bass players don't have to be that good. You just play those
Well,
one
okay.
notes.
Yeah, well, I hear you, and oh boy, yeah, cancer. My wife also, unfortunately, she passed a year ago from ovarian cancer.
Hmm.
Um, your wife is now okay, or or she?
Well, well, she had her thyroid removed like 12 years ago. And so,
Oh,
and it happened when she was young, and we didn't understand what happens when you try to have children without a thyroid. And we were
oh,
successful with one of the pregnancies, but it took such a toll on our body. Um,
oh boy.
so
Yeah.
I mean, they did things that they don't do nowadays, cancer wise, with the radiation with her. And so it was like a learning, a very harsh learning experience for my wife and I.
I'm so sorry. I'm so
Yeah, but it's who I
so
am.
sorry.
I mean,
Yeah, got
I,
it.
I started getting savvy, to the world around me, not trusting,
Yeah,
the
yeah,
talking heads
yeah.
on the
I hear you.
TV.
I hear you. Yeah. Well, okay. So, yeah, it's not so easy. But I just wanted to return before we switch topics to the issue. So you've named something that, at least for you, would be a kind of scientific revolution, something that's occurred in the past 30 years, new information. Uh, that's one. But if you think about it, you know, the amount of money that's gone into science in the past 30 or 40 years compared to 100 years ago when revolutions were occurring practically every year, uh, uh, in physics mostly, but in other fields too. The question is, how come? And that brings me, circling back to the issue, um, that we began discussing, that people feel insecure. They want to be on top, and if someone challenges them, and so the system, the way it works now in science, doesn't allow for challenges to succeed. So, example, um, you everybody out there thinks that the Earth is flat. Okay, I look out, I can see a lake from my window, it's flat, and some land beyond. Look, it looks pretty flat, so it's easy to think that the Earth is flat. But you, Matt, um, you're thinking otherwise. You've seen some satellite photos, and it kind of looks like a sphere, not flat. And you decided to take a trip around the world, looking out the window in your airplane, to try to find the edge of the flat Earth, because it's got to be a cube. Because you take off from home and you go all the way around and you wind up at home. So you've circumnavigated the Earth, and if it's not a sphere, which is pretty easy to circumnavigate, if it's flat Earth, there must be a cube, right? And if it's a cube, it must have some edges, or I mean, it doesn't have to be a cube. It could have some other planar kind of shape, but it's got to have edges. And you look out the window very conscientiously, and you could never see the edge. You just simply didn't spot. So you go to one of the agencies like the National Science Foundation, and they get this application. You say, I want to study this because I have so-called preliminary data, is the way it's usually worded, that the Earth might actually be round. And so it comes to the National Science Foundation, and the gatekeeper says, "Oh, this guy Matt Powers. Let's see. I don't know him, but this looks like a pretty major challenge to to conventional thinking. We all know the earth is flat, and this guy says, no, it's not true. If he's right, it's pretty important. So I think what I'm going to do to be conscientious as a gatekeeper, what I'm going to do is I'm going to recruit the most famous scientists in the area of the flat earth or the shape of the earth to review this, to see if the guy's a crackpot or, you know, what he's saying makes sense. So this gatekeeper is very conscientious. He recruits the most famous scientists dealing with the shape of the earth. Who are these people?
The
The
most
flat earth
vetted,
people.
the most vetted in that way of thinking.
Exactly. And do you think they're going to look favorably upon Matt Powers coming to to displace them in their vaunted positions? No way.
No.
No way. And so what happens is these people get together and they review your application, you know, one person stands up and says, well, you know, I reviewed this and yeah, I got to admit it, it's pretty interesting, but you know, he hasn't suggested the correct statistical analysis or something like that, you know, so we better send him home and let him rewrite this application, come back next year and we'll see. And everybody around the table is thrilled because they don't want you to succeed. They're all flat earth people. You have almost zero chance. And if you ask scientists who are in the system, they'll tell you the same thing. They'll tell you, oh boy, if you have a radical idea, keep it to yourself. You'll never succeed. And it's worse than that because you'll get the reputation of being a heretic. And once you get that reputation, even if you apply for a project to get money to study a project in something that's more mainstream, you won't get it because they already know that you're a crackpot, a radical, and not to be trusted. And that's the reason why we don't see many scientific revolutions, because the system now, the way the system works is it's big institutions. It's not like at the time of Niels Bohr and Einstein and Planck and all those physicists. You know, you didn't need big money to do. They were actually mostly theoretical, but you know, sort of like the constipated mathematician who worked it out with a pencil. That's, yeah, but I mean, nowadays, if you're doing experiments, especially, you need money. And you're at a university and the university expects you to bring in money. They get overhead on top of the money that you bring in. So they're thrilled if you bring in money. But if you don't bring in money, there's no activity in your group anymore because you can't pay for the postdocs and graduate students and supplies and equipment and whatever you need. And you're out before you know it. So it's a matter of bread and butter right now.
Wow.
You want to succeed in science, you got to toe the line. Otherwise, it's really risky. And I think that is the main reason why we've seen so few scientific revolutions. We actually, I'm sorry?
It's like a censorship culture built in, or a cancel culture that's built into it. It's awful.
Well, I think that's a good way of describing it. And, you know, the institutions are aware of this. I, at one time in my life, was very active in trying to change the situation at the National Science Foundation. I was an advisor there. They recruited me, and also at the National Institutes of Health. And I thought I was making some progress because some things changed a little bit, but they so quickly reverted back to the original. When you deal with large institutions, major philosophical changes are really difficult, you see. So that's why we came up with something called the Institute for Venture Science, our organization, which is coming to life. And the idea is that we are looking for grant applications that deal with major challenges to conventional thinking. And we have a vetting system that's as thorough and comprehensive as any I've ever seen. It's more so. And it's a major challenge to do it. Of 200 pre-proposals, narrowed down to about 15 proposals, we selected 5 projects, which, if funded, could change the world. And
wow.
and we're looking for funds right now. If if any of your listeners are, uh, have done well in their life and want to do something meaningful for mankind, I think this is one of the best ways where they can put their money. It's just a matter of contacting me. And so we have some donations, but we're looking for something major to begin funding these projects. And, while I'm on the topic, I can't stop but telling you one major feature of this. You see, if you're the guy who applies and you're anointed by our group and we're about to give you money, you're still not going to succeed. Why is that? You won't. The reason is simple. Because of all those people I mentioned who were sitting around the review table and the other institutions, they're still around, you see. And someone's going to pop up and say, oh, Matt Powers, he's a crackpot. He's got this weird idea that the earth is round. And we all know that it's flat. It's impossible to be round because we can look out and see that it's not round, you see. And you're demolished. And what are you going to do? You're going to stand there, you're going to raise the flag and say, oh, no, I'm not a crackpot. Who's going to listen? This is an obstacle. You see, the more evidence that you can accrue that you're right, the more resistance there's going to be. People will dig in their heels. So we solve that problem. And the way we solve it is by finding another 10 or 12 laboratories, independent, scattered around the world, who also think that the earth might actually be round instead of flat. We fund them too. So you see, now at the annual meeting of the Shape of the Earth Society, it's not just you coming with evidence, but a dozen other groups, independent of you, although maybe loosely connected, independent, who have different measures, who come to the same conclusion. You can't ignore that. And that is going to precipitate scientific revolutions very quickly in multiple fields. And boy, if there's something we really need now to solve the world's increasing problems and our survival, it's scientific revolutions. Scientific revolutions inevitably produce new technologies that nobody would ever have thought of. And the new technologies, the right one, could help us in solving the problems that we're all facing on the earth. So I know I've digressed from what you wanted to talk about, but it's really important.
Yeah.
It's important. Yeah.
I wouldn't be here if it wasn't for Kickstarter. I was a high school teacher, and I started this process of basically, writing books for K through 12 and writing curriculum for college. And then I started talking to PhDs and doctors about their actual published papers, and then discovered, how much discrepancy and disagreement there is among published authors.
oh yeah. Yes, absolutely.
Yeah. I became aware of the waters I was swimming in. But
yeah, understood.
Yeah, but to circle it back, on that topic, on that note of world changing, when I realized that all hydrophilic surfaces in nature polarize in the presence of water, in sunlight especially, to form this gel on their surfaces, it began to change everything. Like we mentioned before, that the idea that, well, plants do this because fourth phase water is. It's just a part of reality. And so they had to evolve that way. It's changed the way I see evolution playing out. It changes the way that I view energy movement through the soil, through plants. Something that I've always wondered about and people have talked about, and I think that easy water might answer, but I want to hear from you.
Easy. So we haven't discussed, first of all, why easy. Fourth phase, I guess, is understandable because it's different from the other three phases, but we call it exclusion zone water because this kind of water is like a crystal. And crystals, when they form, like ice crystals, for example, when they form, they're pure. And in order to be pure, they have to get rid of or exclude all the junk that is was sitting in the water. You see, and so we originally discovered this kind of water, looking through the microscope, when you have a volume of this kind of fourth phase water, it excludes pretty much everything from it. So someone suggested, why don't you give it a name? And at that time, we didn't think of fourth phase. We said, okay, exclusion zone, EZ, easy to remember, right? Except, unfortunately, it doesn't work in most countries because the Z is a Z. So it's in Europe, it's EZ water. And, you know, it's not as cool as EZ to remember. But anyway, the sun is critically important. And what we found is that to build this fourth phase EZ water, which is highly structured, organized, you know, if you go from chaos, the structure of this kind of water, to order, you'll have to put in energy to achieve it. Otherwise, things tend to randomness. But if you want to, if it's like cleaning your room, you know, you don't need to do a whole lot. It gets messy, but you decide one day, oh shit, this is too messy. I'm going to clean it. It requires your energy. You have to put time and energy into straightening the room so that it's neat again. And it applies in every situation. If you want to create order, you need to put in energy. Disorder is natural, but you need energy. So we were scratching our collective heads trying to figure out how you go from ordinary water to structured or easy or fourth phase water. Where does the energy come from? You know, obviously you can't plug into the receptacle 110 volts. So where is it? And we found out because of a student who was doing what he was not supposed to be doing, that it was light. So he was, and get back to the sun for a moment, because you know, in the field of agriculture, obviously we're dealing with sunlight. Mm-hmm. So he was doing an experiment on the lab bench, and sitting next to him was a gooseneck lamp. So he's looking at the fourth phase water in the experimental chamber, and he brings the lamp over, shines it on the experimental chamber, and the region that was being illuminated, the EZ water grew enormously. And so he called me over, take a look, and I'm thinking, wow, this is very interesting. So I told him, turn off the lamp, and it came back to its original, so it's reversible. So we did experiments trying to figure out which wavelengths were the most important. And it turned out it's not the visible wavelengths, it's actually infrared. It's not ultraviolet, not infrared. Yeah. Well, you laugh. Well, why are you laughing? Because you expected.
Infrared is such a big deal. I think that when you start looking at the fact that some plants can photosynthesize with just infrared, when you look at,
I didn't know that. Is that right?
That's what John Kent was talking about last time we.
Well, I would love to see the evidence for that. Very important. Because I've spoken to some of the people studying photosynthesis. The ones I spoke to don't know anything about the infrared. But see, if infrared is what grows EZ enormously, it has an enormous effect. We could get the size of EZ to grow 10 times with a simple little LED. It generates such weak infrared. And the sun, as you know, half the energy coming from the sun is in infrared. So when the sun hits the plant, it builds EZ water. Just like when you walk into the sauna in the heat, grows EZ water. And if you're not feeling too well, if you want to restore your cells if you want to feel better, you restore your cells that may be deficient in EZ water with more EZ water, and you come back to normal, if ever you and I could be described as normal, but so to speak. Sorry. Yeah. So yes, absolutely, and you know, the plants are just filled with EZ water. So you didn't ask me, but one of the issues also discussed in this fourth phase book, where a lot of this stuff is, how does the water get to the top of a redwood tree? right?
Right.
You know, still not so clear, but we found something in the laboratory that we think can answer that question. It's not just it's a propulsion mechanism that we discovered that uses energy from the environment, like infrared energy, for example. So another student, these are undergraduate students, you know, young 18, 19-year-olds, fresh, vigorous, and open-minded. And so we had been using a polymer called Naphion. It's a very hydrophilic polymer to study the fourth phase, because next to this polymer, the fourth phase water grew very nicely, and it was easy to obtain. And we found out that it also came in tubes, like a straw, that geometry. And so we were asking the question, we can see that the easy water grows next to a flat surface, like a sheet of Naphion. Could it also grow next to a cylindrical surface, like these Naphion tubes? So I asked the student to do it, and he did it. And within a couple of weeks, he had confirmed that, yeah, it's true. But one day, right after that, he comes barging into my office, and I was sitting with some visitor, I think might have been an important visitor, but I don't know, somehow the conversation was not so intriguing, so it was okay. He came barging in without knocking or saying, you have a moment or something like that. Usually the students are polite. I don't encourage politeness, but they tend to be that way. So he comes barging in. He said, you know, I saw something in the lab, and I thought I would tell you. It looks like it might be really important. He said, I put the tube in the water, lying at the bottom of the chamber, horizontally, like a straw, oriented horizontally. And he said, the water just keeps flowing through it without stop. And I thought, my God, if he's correct, this is really important, because usually, you know, if you want the water to flow through a tube, you have to put pressure to drive it with pressure. It's just like your heart beats and, you know, creates pressure to drive it through. So, and I was thinking back of my mind right away that we know that the infrared wavelengths are absorbed by the water, and that absorption of infrared wavelength does work. It creates order, it separates charge, it builds potential energy and such. And I thought, well, maybe that would be the real driver of this effect, which turned out to be true. So basically, to make a long story short, we found a mechanism that is dependent on the exclusion zone growth. It grows inside like an annulus, negatively charged, and the positive charge, the equivalent positive charge, is right at the center line in there. And all those positive protons are repelling each other. They want to get out because of that repulsion, and they will leave either one end or the other end. And once they start leaving, they'll drag more water in, and the process keeps going. And it's all fueled by the infrared. So when you think of plants and trees and xylem and phloem and all these flows that are whose driving forces are, you know, not so clear, I think the phenomenon may be the same as what we discovered in the laboratory, that this is being propelled. It's being propelled by the infrared energy that's coming in, and that may be why in the springtime, when you're beginning to get a lot of this energy, the flows begin to pick up. Because they're propelled directly by this kind of energy. So I think this is, you know, for me, exciting to think about why this happens. It's not just in the plants, but it's also in you and me. We found other experiments just completed that it helps drive the flow, the blood in your cardiovascular system. We found that, you know, if you stop the heart, you expect the flow to stop. It doesn't stop. It actually keeps going, although at a lower velocity. So something else is driving it. And we found out that in the capillaries themselves are propelling the flow, just as the heart propels the flow. So in your body and everybody else's, it's not only the heart that is driving the flow. It's also the capillaries themselves that are driving the flow. And the same thing in other tissues, like lymph, for example, inside the body. Lymph flows, but nobody knows, what's driving that flow. And I think it's the same thing we're talking about. Inside the body, the infrared energy comes not only from the sun and everything else around, but all the metabolic reactions that are taking place inside your body are generating heat, which is essentially equivalent to infrared. And so that's not wasted. That is actually going to use to drive blood flow in your body. So I'm excited about all this stuff, as you can guess.
Yeah, I'm fascinated with all of it. The Spitzenkörper, the tip of the mycorrhizae, it can move to other parts of the mycorrhizal body nearly instantaneous, is what the literature says.
Yeah.
And then there's always the prerequisite that there's enough moisture, right? For mycorrhizal to throw.
Oh, enough moisture. Yeah.
Enough moisture. And in my mind, I'm like, you mean enough fourth phase water so that it can translate that, right? Isn't it? Yeah. They've got to be connected.
Oh, I think very, very much so. And we see things as the fourth phase grows, it just pushes everything. So movement is really very easy. And all the charges involved can easily either repel or attract. So it's just full of potential energy. It can do all kinds of things. And indeed, it's quite possible that much of the energy inside your body comes from that water, that fourth phase water. And of course in plants too, the same thing.
Do you think that we used to live in a world that was more, the world that was more robust, more wild? Did it have more fourth phase water? And because of that, were things healthier?
That's a good question. This is pure speculation on my part, because I wasn't there at the time. Although sometimes, given my gray hair, and lack of hair, I kind of think maybe I should have been there. Maybe I was there at that time and I've just forgotten. But yeah, it was a time that we lived more naturally. And I think many of us, particularly those in the medical profession, tend to denigrate the wisdom that existed at the time. For example, in the Ayurvedic culture, where many of the traditions from 3,500 years ago have persisted, and we have new evidence why some of those herbs and such are good for health. In fact, we published some papers showing they build fourth phase water. We did experiments and determined that. So
like holy basil?
Next time basil is, holy basil is one. Turmeric is another.
I grow turmeric.
Well, there you go. So keep eating it, using it, whatever, and modest doses. It builds easy water. And I think, since you need a full complement of easy water for your cells to function properly, eating this stuff, taking it with your food, should be helpful to you in promoting health.
So
it's
like
really
alginate?
simple. It's not.
So do you take like alginate water, like thickened water, kind of?
Well, I haven't, but we know that fourth phase water grows next to alginate. We tried that. We have studies demonstrating that. So and also on that topic, people take the plants and they squeeze out the juices, and then drink the juices. Right. Juicing, so-called juicing. I don't know if you do it, but so why does that promote health? And apparently it does, because many of the health providers that I've spoken to, they suggest that for their patients. Patient comes in with this problem, that problem, 5 problems, doesn't matter which problem, start juicing. And they do it. And they come back a few months later, according to what I've heard, and they feel a lot better. They've also lost weight. What's going on? And so, if you think about what you're doing by juicing, you're squeezing the water from the inside of the cells of the plants. That's easy water.
Right.
So you're squeezing out easy water, and then you're drinking easy water. So by drinking easy water, you basically have an opportunity to replenish what might be missing in the cells where there's not a full complement of easy water. It's really simple, you know.
Wow.
So I mean, I think that's the reason.
We
So
did
a lot of
juicing for
things
my
fall
wife.
into place. I'm
We,
sorry, what?
we did the juicing for my wife. It drove me crazy. We did like 8 juices a
It's
day, and I was cleaning everything constantly.
what
But
a good husband. What a lucky wife. And what happened? Anything, any improvement?
you know, she did get better. That was like when but what I realized was I couldn't keep doing it, and I also had to just find food that was like holistically better, and I couldn't just, you know, take mediocre food and then juice it to get like, you know, enough for her. We had to just eat better food, and that's what
Yeah,
really
better.
got me growing like crazy, and what started my whole journey.
Yeah, I hear you. Yeah. Well, what a devoted husband you are. Good for you. Good for her. Good, and good for your kids too. Fantastic. Uh, well, where are we?
Well, we were just talking about how to increase the fourth phase water of the body. I am so excited. I feel like so it touches upon so much of our journey. And I think that so many people are going to take so many different things from it because you expose something fundamental to everything inside and outside of us. And I feel through what I've been studying in the soil, and you've gotten to see some of it, and fourth phase water is throughout the whole understanding that I now have, that the world is completely new. The world is completely different from I always think of it as like the 80s story of the world. And it's
Yeah.
thrilling for me. And I really appreciate you coming on and sharing with us from your own experience doing this, liberating this kind of information for us so that we can open the door to new understanding.
Well, thank you for your kind comments, Matt. For me, um, it's so exciting to be able to do this and to share whatever, with the world. And I've got more coming. The first is I do recommend, this is not a matter of selling books, but the fourth phase of water book is all of the stuff I've been talking about is in much more detail, and there's so much more in the book. It talks about water and common experiences that now are easier to interpret with the new paradigm. And I've got some new books on the way, and I'm working assiduously to bring them to completion. Problem is my son. My son is the artist. He's a gifted artist. He's actually a sculptor. He didn't illustrate the book that you showed, but the fourth phase book he illustrated that one with cartoons, and people comment on on the cartoons and such, and it makes it more accessible.
Mm-hmm.
But I'm working on two books. The immediate one has to do with the role of charge in our life, electrical charge.
Yeah.
And I think it's overwhelming. We have completely ignored the role of charge, and I think it's so pervasive that it occupies a centerpiece from phenomena ranging to what creates the wind, to why the earth turns on its axis, to what makes weather, to how birds fly. And the one after that deals with the structure of the atom. I think the textbook view is not correct. I see that your eyes are popping.
This is amazing. I'm so excited. I want all of these books.
Well, I'm working on it, and one objective in writing a book, you think when you write something, it's really clear to you, but it may not be clear to anybody else. So I get feedback from people. I have a couple of editors who are helping and such to bring the book. The ideas are there, but the presentation needs to be worked on to make it accessible, which is what I'm spending a lot of time trying to do. And as far as the atom is concerned, there are some I used the term middle school earlier, and there are some middle school kinds of objections to the current uh, picture of the atom.
Yeah.
And I think it's wrong. And I put forth, or I'm going to be putting forth, chapters are already written, going to be putting forth what I think is a superior model that explains more and doesn't suffer the contradictions that the current model suffers. It's a kind of uphill battle because, you know, it's been the so-called Bohr model, which has undergone many changes with the advent of quantum mechanics and such. You know, it's been in our textbooks now for 5 generations. And
Yeah.
so it's hard to think that it could be wrong. You know, but I think it's wrong. And so,
Well, have you seen the new imaging where they're traveling through the cell? It's a 3D image of the cell, and it's like a holographic imaging.
I've seen some like that. I'm not sure if it's the same one as you're talking about. Yeah.
Yeah,
What about it?
I imagine that we're going to be able to see and understand so much more when we can start, you know, making those kinds of things more accessible and make. I mean, if we could view the world through the charges, like if we could put on a lens and then see charge, you know, electrical charge, I think everything would be different. I mean, for me, in just learning about, you know, the molecular side of things, it changed everything for me in the way I view these things. But do you think that, how do you, and this is a tangent, but it deals with the way we start educating about many of these things. We start so often in education with children focused on the atom, and when we say, there's special scientists someplace that can view these things, but you can't. Just take our word for it. Have faith. And I really want them to actually be like doing the cheek and then putting it on the microscope and looking at it and being like, that's me. And be like, yeah, what do you see? You know, and having them be the discoverers of the world around them and have that be the seat that we start science.
Well, yeah. So the science is presented to us as fact,
Mm.
you know, absolute fact. And I agree with you. I think the proper way to teach is to let the students learn themselves by doing or thinking or whatever. Just guide them to their own thinking, and sometimes that thinking will bring up conflicts with you know, current thinking. So I'll just give you an example of this, and this is like the wrong way. So the students are taught, oh, here's the structure of the atom. We got a nucleus in the center, and it's got protons and it's got neutrons, you know, right in the center of the atom. And then we've got all the electrons that are in orbits around. Oh, okay, so that model has been changed a bit, but basically it's the fundamental model that most of us learn and most students learn to begin with. And first question is okay, professor or teacher, that's pretty interesting. You know, all those neutrons and the protons, and the neutrons are neutral, but the protons are positively charged. So when I'm thinking about the nucleus with all of those positive charges stuck together, they want to repel. What keeps the nucleus? Why doesn't it explode?
Whoa.
And you know, so fundamental question. Of course, the physicists have faced that and they've responded. And the way they've responded is to create something called the strong force. Right. You know, it's like some wizard that is capable of you know what. And it has just the right characteristics to hold it all together. Someone invented the strong force. So, you know, if there were independent evidence of a strong force that does that, that's fine. But this is a Band-Aid to cover a gaping wound. And if you think that that one is serious, think about the next one. So you've got a nucleus that's positive, and you've got electrons that are negative. What happens when negative and positive come near one another? Well, they attract. So a question for you or anybody, how come the atom doesn't collapse into nothing? plus attracts minus. So those are just a couple of examples of, of if a student, if you had a student and your student were to come to you, you asked a student that came from a different universe or something, or a different galaxy, landed in your room, and you said, "Hey, I'm looking for a theoretical model of the atom. Could you come back to me in a week?" And if they came back to you with that model, you'd say, "Oh, come on. You can do better than that, because this has obvious flaws. The nucleus will explode and the whole atom will collapse on itself. You can do better than that." So I just will leave you with that, because these are middle school questions, right? And if the teacher comes and says to the student, not, "This is the structure of the atom, and you can't see it, but we know it because famous scientists have 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 come forth with this model, and we got to believe them, and it's a fact." The other way to do it is to let the students say, "Well, okay, we have these subatomic particles. How would you put them together in a way that makes sense, that maybe could explain a few things?" And I would bet you that a lot of the students won't come up with the current model, because they can immediately see it doesn't work. See, but it's part of our, part of so-called ground truth. You start with that model, modifications of that model, but the essential backbone is still the same.
So this would
So we got a lot of
into
problems.
the idea that when we go and look for things, we find it mostly empty space. This would tie into this kind of black box kind of relationship we have with this space.
Well, yeah, I mean, that feature, it was a good question. I think that it's possible to live with some empty space if the structure has to be stable. You see, the existing structure is not stable. It will either fly apart or it will collapse into nothing. You need something that's stable. So
what I mean is, that we don't really understand. Have we seen it enough to really see this structure, or are these just guesstimations? Have we actually?
They're guesstimations. Nobody can see an electron.
That's the problem. That's crazy. How do we arrive at stable places for people to move forward on things? It feels like if we just keep doing things like that.
I think we act. Yeah, go ahead.
I was just saying. I was talking.
Well,
oh no, you go ahead.
Well, I think we need to go back when we read a textbook, and when something is presented to us as fact. Right. We should not accept it. We should go back and say, well, gee, what's the basis on which this fact has been arrived at, and does it make sense? And if it makes sense and is useful, then maybe we can accept this as being at least tentatively reasonable. But if it doesn't make sense, if there's not real evidence in support and no logic, or if it defies logic, then we have to begin again and ask ourselves whether these foundational paradigms are really valid. And it takes middle school students to do that, because once you're mature, quote unquote, you have a tendency to avoid questioning the establishment point of view. That's the way it goes.
Wow. How do you feel now about your body, the world around us, the muscle of the landscape of the soil, right? Because it's holding it all in gel, and then it all connects and ties into all these different metaphors and connects ourselves to the real world in a completely new way, a profound way. And so for me, my brain is still turning on all this stuff. And I hope it is for you, because this is not something that will just be like, I got it, everything's understood. No, this is like the disruption of everything. It's like we only did the first imaging using an MRI imaging of a single atom a year ago. We haven't seen an electron. we're just, trying to understand the weak force, right? We're just beginning to crack so many of these ideas open. And it, I know that we talked about how like there's not enough funding, and how these new revelatory scientific discoveries and archaeological discoveries that we see out in the world, and plant discoveries, all these different things that keep coming up, they're being spread by mediums like this podcast, through mediums that are alternative media, that are not the mainstream media, the mainstream narrative that chops off anything that could bring contradiction, bring deeper meaning, bring any detail. And it is listeners and viewers like you that promote this and keep this alive, and allow so many of us who are like John Kempf and Dan Kittredge. You help us do the work to connect all these scientists, to bring things down into a generalist understanding, so that people can really start working with plants, knowing what to actually expect to happen in a regenerative setting. And what do I mean by that? Well, what I discovered in my book is that, and you can discover this from the previous interviews I have with lots of different scientists, that what we thought of as the right way to do things, as what is healthy, as what is a metric that actually measures what we think it measures, has come to light to be not true. In recent years, decades, our science has faced this crossroads where we've had to really accept that we're all in this constant updating, this constant renewal and discovery, versus the 80s locked in, this is the story of the world, and it's just, we've figured it out. It's like, that's not true. We've not figured it out. We don't have clear understandings of a lot of these deeper things. And that's kind of why I stopped at the cell, because I knew in my book, Regenerative Soil, because I knew that there's a lot more we need to work out. I mean, we did the first 3D imaging of a living cell in the past year, and it's not accessible to every scientist yet. And we're talking about the top scientists don't have access to this yet. So we're in a really interesting space where entry into this zone is possible for everyone, because everyone's restarting over and having to rethink everything, and then take what they've known and either throw it out or completely rethink it. And so that's really, I was telling my mom, she was like, this is the best science, sweetie. And I'm like, well, this is what we know, right now, the honest answer of what we know. And not like the 80s textbook answer, the media answer. This is actually what's going on, and the edge of uncertainty that we're wrestling with. We only have identified 1% of the soil biology, in the soil. And primarily, and I emphasize this, in like a sub-thema kind of way in the book, but most of the plant growth promoting rhizobacteria we've already been using for other purposes in the laboratory setting. And so it's like Bacillus megaterium or megaterium. It's a giant, microbe, and we used it as a standard model. And we did things. It's like, why is E. coli so prominent? E. coli is in every laboratory. And so when we teach people chemistry, when people do things in chemistry, there's certain microbes that they're using. And we discovered that a bunch of them also are good for plants, and now we're discovering them in living plants, and it's evolved. And so we're just at the beginning of this, because our plants have been denuded of these endophytic and also mycorrhizal and also rhizobacterial relationships, such that we're kind of dealing with, and I talk about this in the book, we're dealing with a table with one leg, or a wagon with one wheel. And unless we do the work to rebuild those things, we're not going to have a full understanding of what's going to happen. And we have glimpses, as John Kemp and I talk about, there's glimpses into what is possible, what can happen. The envelope of time will shrink. You'll get maturation and the best food happening faster. You'll get multiple yields multiple times a year. You'll see foods that always had pest problems, never have pest problems, are blight and bacterial and virus resistant. And you'll see all these things happen all at once in a cascade. And at the same time, the soils will gain in soil organic matter. So we have glimpses of what's possible, but we don't know what it would be like if we did that regularly across the landscape and if we all ate that kind of food. The kind of health that we would have, the kind of thoughts. Because I mean, our stomach brain is a huge part of what influences us emotionally. So I just think about all this stuff as I think about my body's jello water, and I look outside and think about the rain and the, if there's thunder and lightning and the nitrogen that's being fixed through that nitrogen, through that lightning and the rain. And then, you know what I mean? I like think about all these things, and I think about the difference in charge of the rainwater and the ground. And I think about it all. I suggest that you check out, if you haven't already, Dr. Gerald Pollack's TED Talk. I'll put a link down in the description. Thank you so much for listening. We have 3 days left until the Advanced Permaculture Student Online starts again for the 4th season. This is an incredible program. I created this program so that people could not just learn how to create a design and get their official permaculture design certification, but also how to install it, how to manage it, how to troubleshoot it, and how to expand it and mature it into the future. Because that's what a community requires, and that's why I made my course, the Advanced Permaculture Student Online Lifetime. So if you're looking for a lifetime community to be partnered with a community of lifetime learners who are laterally sharing and collaborating and discussing ideas, because as we talked about today, so much of this is the kind of territory that we need to talk about, that we need to work out together, that we need to generate these visuals, like in my new book, The Regenerative Soil. We need to have discussions in a group fashion. We need to work these things out. That's why, I have my books peer reviewed. That's why my course, The Advanced Permaculture Student Online, has over 70 educators. It's over 180 hours of education on video. And then the audio is downloadable so you can listen to it anywhere on the go. This course, it happens once a year. And we're doing it the original way, which is 20 weeks. It's going to be intense. If you want to be part of this, it's going to be amazing. But know that it's also self-paced. So you join our community, it's a lifetime member. That means you can take your time. You can even join and then next year take it live again. You can do it again. And so this is about making sure that we do the permaculture, making sure that we live it, because if we've got questions, if we don't know how, if we need help, all those different things, this solves that. So, and it also allows, it provides for students to become teachers, to become guides, so that it truly is lateral. It's us together teaching you. It's us helping you arrive at that new abundance, that new regenerative world that we all are interested in making happen. We start Monday, but it's not a Monday thing. It's Fridays. We have live Q&A every week for 20 weeks. We take off 2 weeks at the end of the year for us to focus our minds and get ready for the new year, and 1 week off for Our Future. If you haven't registered for Our Future, our-future.world is the place to go. And we're going to be covering everything, the holistic regenerative spectrum of permaculture. So join us. It's 60% off right now. There's incredible bonuses. There's physical books as one option. There's so much. So, and actually, I'm going to let something else out of the bag. The Permaculture Student 2, the 3rd edition, is coming out in hardcover. And that's included in the full enchilada sign up for the Advanced Permaculture Student Online right now. So check that out, head out, go on over there. The link is below. This is the time to sign up. It's an incredible community. People say it's the best permaculture course they've ever taken. And you can check out all the reviews there. You can listen to my students, talk to my students. They're very enthusiastic, very excited. Many of them are PDC teachers, but some of them are just starting out, just learned about permaculture. It's designed for everyone to start at the beginning, relearn it all at a deep, deep level, and apply it together and make it real. And that's what this is about, making it real, making that regenerative future possible and a reality for everyone. That's the purpose of this podcast. That's the purpose of my books. That's why I give them away free on my website, thepermaculturestudent.com. And that's also the purpose of the Advanced Permaculture Student Online, to make it real in your life. I'm Matt Powers. Grow abundantly, learn daily, and live regeneratively. And I'll see you soon. Thank you so much.